Hi everyone, my name's Ryan. I'm the creator of the Origin HDMI switch. The new version that is going to be open source is anywhere from a 5 to a 25 port version with either a 3.2-inch display or a 7-inch display. I'm basically just a hobbyist at all of this, and if you have some improvements to share, by all means please do so, hopefully politely. There are definitely things I would like to add to this. I would love to add, Wi-Fi capability and have like a phone app to control it and that kind of thing. I use my, spare time for this, but I don't get a whole lot of spare time. So I had to draw the line somewhere, and I had to cut some of those features, and just hope that somebody else will add them back in down the road. I'm sorry, my recording setup is very low budget. I was trying to do a 2-camera setup, but my iPhone overheated midway through, so it went back to just a single webcam. Alright, I'll get you started on the video. I want to show you a couple of them here. This is a 25 port version with a 7-inch screen. There is the back. The ABCDE ports there, those are the outputs of these individual switches. This is a 5-port commercially available switch, looked like this originally, that is now integrated into this, and so I have to use an interconnect to go from the output of one of these guys down to the input of one of these guys. So this bottom switch here is basically the hub for all of the switches above it. They all interconnect, down with jumpers, HDMI jumpers from here down to here. And then the output here goes to your television. So I know some people are going to be upset about external jumper wires. Sorry, it is what it is. I looked into ways to doing it internally, and it's expensive, it's time consuming. I couldn't find the parts readily to do what I needed to do, and I had some issues with interference when I did try it, and it just isn't worth the effort, in my opinion. If somebody has a difference of opinion there, I am all ears on better ways of doing it. I had come up with some connectors that I would desolder one of these HDMI ports, the output port over here, and then solder in a connection for like an FFC cable, to go through. Had interference issues. I needed to try shielded ones, and it just was a big hassle. And the cables are all hidden behind my entertainment center, so I really don't care. This saves a lot of time and effort and makes my life easier doing the jumper cables here. So anyways, this is the 25 port. This new design is modular, so I can do that larger case with the 7-inch screen. That has 6 5-port switches in it in order to make a 25-port switch. The bottom switch is basically just the hub switch, so you don't get those extra 5 ports because that's what's controlling everything else. You can do any number of switches in there, and the number of ports goes down by 4 every time you drop a switch. So, there's the 25 port, 21 port, 17 port, so on. I also have designed a smaller version of it with a 3.2-inch screen, and this one I've got pre-made here has 13 ports. You can still do 13 ports in the larger enclosure with the 7-inch screen, which might be nice depending on what you want to do. But for a little bit more, small, low profile device, I've got this smaller design as well. And I've already got one of those. That one's a 13 port. I've got one here that is, I haven't put the top on it yet, so you can kind of get a sneak preview of what the insides look like. But this one's a 9-port version. And just for the interest of time, I'm going to be building today a 5-port version. It's the same process for, just multiplied out. So every time I add another switch, it just duplicates that amount of work. So there's no point in me filming, recording, or making the 25-port version, because it's the same thing 6 times over. So at any rate, I'm going to basically start from the beginning here so you see the whole process. This is more or less what we're going to end up with. I know there's a little bit of a wiring rat's nest in there. Apologize for that. I don't have a great way of managing the cabling here, but you get the idea. I'll show you this in more detail as we go. Try not to take up the whole time talking. Show some soldering action here. Alright, so I'm going to start with disassembling one of these. This is a commercially available HDMI switch. I've already taken the packaging out and all that. Try not to do too much boring stuff on camera here. We're going to use that. We're going to use an Arduino Mega. I've got that unboxed here. And we're going to use a next-gen screen. This is the 3.2-inch version. And yeah, I've basically designed it around the 3.2 and the 7-inch versions, largely because their resolutions are, exactly half or double, depending on how you look at it, each other. I just thought that might make the user interface design a little easier. In reality, it could be done with any size screen you want, but the 3D modeling would have to change and some of the programming would have to change. So, let's go ahead and, a couple other components here. Just a power plug and a power switch, and this is a level converter. The Arduino is operating at 5 volts and the HDMI switch is mostly operating at 3.3. So we use this to adapt the voltage there. And then I've got a little SD card reader. This is going in there for the storage, for saving the names of the inputs and so forth, since the whole idea is to keep the switch programmable, so you can make it very user-friendly and actually have the inputs labeled. Alright, so let's go ahead and disassemble this. There's one little security sticker here, warranty sticker, whatever. You can just stab right through that with your screwdriver. I'm going to go ahead and switch cameras. See if that helps a little bit. I only have a 2-camera setup here. I am not a professional streamer by any stretch of the imagination. I've only made a handful of YouTube videos, and they're I don't have a professional video setup. This is actually the most professional I've done with a 2-camera setup here. So we'll see how this goes. We're not going to use the case, so we can just throw that away. There are 4 screws, holding the case together, and then there's another 4 screws inside here holding the actual circuit board down to the case. Throw the case away. I normally save the screws, but I've got so many of them at this point because I've done a bunch of these. I'm just going to throw these away. Alright, we don't use those screws. I've designed the case for screws that are meant for going into plastic, whereas those ones are designed to go into metal. So the plastic ones have cut threads into the screws for plastic, rather, cut threads into the plastic and really grip down well into the 3D printed case. Okay, so here's the circuit board. We've got to do some prep work here, desoldering these LEDs. That's how the origin switch senses which input is active. We're tying it to each of these LED pads, the through-hole connectors here, so that it can tell, if there's voltage going to this LED, then it knows that input is active. We're also going to desolder the power LED so that it can turn the switches on and off and know whether they are on or off. And we're going to desolder the infrared receiver here because we're adding our own. And I realize I don't have that out on my components table here. I'll have to dig one of those out of my bins in a second. Alright, we don't need the infrared receiver for a little while. So I'm going to go ahead. I've got a desoldering gun here. This is a Hako, or however you want to say it, FR300. This is one that I picked up from, watching some other YouTube electronics people. Again, I'm all self-taught. I've spent way too much money on this hobby. I cannot justify it by any stretch of the imagination in terms of making anything financially out of it, but it's fun. You don't necessarily have to have one of these. You can use a regular soldering iron with desolder braid. I've got some of that here as well that I use for some of this stuff. But this does make things a lot easier. So once that's up to temp, the light just went out. I'm going to go ahead and start desoldering here. And I find it helps to kind of wiggle around a little bit to make sure that it gets all the way around the pin that's coming through there. You can see that was definitely getting loose there. They don't always come out on the first try. Sometimes you have to add a little solder, which seems counterintuitive, but it works. Fresh solder gives the gun something to suck on if there's not enough material there to establish a vacuum. So this whole project, by making it open source, I'm hoping that the community will pick this up and improve on my design here. I know just enough to be dangerous about all this stuff. I'm an IT guy, IT administrator, by day, but this is all pure hobby stuff for me. I just find it interesting, and I've picked things up online, and I enjoy it. But this isn't something I've ever been professionally trained. Haven't gone to school for any of this stuff. So by all means, if I'm doing something terribly wrong, politely show me a better way, and I will be all the happier to improve my technique. Okay, so I've got those removed. We also need to remove the power connector here. For that, I'm going to use a hot air station. I've got the Quick 861 DW over here. Let me switch cameras, you can see it a little bit. So that guy is handy for removing stuff like this. You can do this with desolder braid. You can do this with the desoldering gun, but this has a lot of metal that you got to heat up, and I find that depending on how you do it, you can start to melt the plastic, which makes it hard to remove. And I just had a nightmare of a time trying to remove this without the hot air station. But if you're determined or more skilled than I am, then you by all means can do that. I'm using just a scrap 2x4 here. I find it helps to set the board upside down on top of that. Let me get this out of the camera here. And then grab a pair of needle nose pliers and grab a hold of the power connector. I gotta set the temp here. I'm gonna run my hot air station at around 400 degrees Celsius, pretty hot. And what I'm gonna do is grab a hold of the power connector with the needle nose pliers and just kind of do a little rotating motion here to heat up the solder on all three of these solder points to this connector. I've done a bunch of these. I've never damaged anything nearby or anything like that with the hot air. I know it is operating pretty hot here, but it seems to work pretty well. There we go. Okay. So that is done. I usually will go back later and clean those holes up with my regular soldering iron. You can add some solder, and you can either suck it out if you want to clean them up, or just add to it and then push the wires through. We're going to eventually hook up power wires, new feed wires to power this there, so it doesn't hurt to just fill them in with solder for that purpose. Okay, so this board is prepped. as far as removing components is concerned. I'm going to go ahead and stick on removal right now and go to the Arduino board, and I'll also go ahead and do the SD card reader. I got to remove components from both of those. Let me get my hot air station out of the way here. I'm working in a pretty limited space, but I've made it work for what I do. Alright, so I've still got my desoldering gun on. I'll clean up the tip a little bit. Let's go ahead and do this one first. This is, I don't know why, but this tends to be one of the harder ones to desolder. I think it's because it can't get a good vacuum to suck all the way through because of the plastic here or something, or maybe it's the solder they use, I don't know. I'm going to try, let me turn on my regular soldering station. It's the Hakko FX888D that I'm using here, with just the tip that comes with it. If that'll focus. It will not. So you get the idea. That tip works for just about everything I've been doing. I do have some other ones that I use for some things, but alright, I'm going to go ahead and, just because I know this tends to be harder to desolder, I'm going to go ahead and add some solder to hopefully make this a little easier. So why am I desoldering all this stuff instead of just using these pins and, you know, using jumper wires to this? I tried that first. I really, I did. I wanted it to be easy, where we just hook up jumper wires and we've got removable connectors and everything isn't soldered together. Maybe there's a good way to do that, but what I found with the wires I have been using, I think I've got a couple around here I can show you. You know, I just use these cheap jumper wires, and maybe these just are terrible quality, I don't know. Apparently I'm losing my other camera because I was using my iPhone and it got too hot. So I'm going to do everything on this camera. So at any rate, I was trying to use jumper wires for all of the connections here. You know, I would like solder them to the HDMI switch, and then, you know, use just the you know, pin connectors on this side, you know, like so. But I found that that connection was not at all stable. I would have weird things happen. It just dropped out. So I couldn't trust it, so I decided just to solder everything. If there is a connector, a better cable, you know, with a plug-in connector or whatever at the end that would do this and be stable and reliable, by all means share what that connector or cable would be, and it would make this a little easier to do. You wouldn't have to desolder these, you know, ports on here, the pin headers on here, and you know, you wouldn't have to, you know, work as hard with everything all tethered together. It would be a little more modular. But based on what I know and my experience of doing this, that has worked the best, is to just remove this stuff and solder everything. It's a little more labor intensive, but it works reliably. And reliability is what I'm after here. I'm going to take a little more time on this and not go too fast, because I know that this tends to be problematic. Not completely sure about that ground one there, but the others, I think I got all of them. Yeah, I definitely didn't get the ground, but I got everything else. Let me try adding some solder to that one. Ground is always the hardest because it's got so much metal to heat up. Leave the soldering gun on there. That looked promising. Alright, set that aside until it cools down, and then I'll just throw it away. Okay, so that's done. I'm going to go along here. In this case, I only have to remove this pin header here and this bank here. I guess I probably should remove the power one here. I don't have to. I could hook up power over on this side. I just like to hook it up where the voltage in is expected, but it does seem to work. There's a 5-volt plug here and ground down here that you can use. Oh, and real quick before I forget about it, I want to remove this fuse here. I tend to forget that one. What that fuse does is protects against voltage from the USB port, like causing a surge and burning something out or whatever. But we're actually going to, by removing it, we're going to basically unhook the USB voltage to the board. And the reason we're doing that is this all gets hooked together. And so that USB port is going to, if you plug it into a computer or whatever, it's going to try to provide power to not just the Arduino, but the SD card reader and the HDMI switches that are in there and the next-gen display. And it just doesn't provide enough power to do that, so your equipment starts behaving really weird. In order to be able to reliably operate this device and program the Arduino, we're going to require external power. And we're going to require it by making sure that the USB port cannot provide power to these devices. So I'm going to go ahead and use the hot air station for that because I've got it here and ready. There we go. That was a lot easier. Alright, I had it at 300 originally, bumped it up to 400 degrees Celsius, and that made all the difference. I always try to start on a lower temperature because, I don't have the experience to know for sure what's best, and I err on the side of caution as much as I can. And that might have eventually worked at 300 degrees, but it was taking a long time and I wasn't patient, so. Okay. So you can desolder these with a hot air station if you want, but I've been using my desoldering gun here, and I find that works pretty well. This is hot over here from me using the hot air station on it, so I got to be careful about that. Yeah, it's still pretty warm even on the edges there, so let's just do whatever we can without picking it up at this point. This is very hit and miss. I'll get some where you can clearly see that the hole is nice and clear of solder, and some where it is not. And what I'll do is I'll go back later, and the ones that you can see that they aren't clear, I will, like that one, I will, well, that one worked on the second try, but if they don't, suck clear there, then what I'll do is add some solder, and then, yeah, like that one there. I'll add some solder and then, desolder it again. Let's try that one now just for demo. It's a little easier to add solder with the regular soldering iron, but it works using the desoldering gun too. There we go. Got both of those. It's actually working pretty well to add just a little bit of solder while the desoldering gun's already on there. Okay, got that. And the power one's down here. A lot of times I just remove all of them, all of the pin headers. I don't know. It's not technically necessary. It does provide a little bit cleaner of a look, and then, if down the road I go to add anything to this, they're already gone. So, if any of these come out without too much trouble, it'll be a miracle, because these are always a pain in the butt. So what I'm going to do, slowly wiggle them out. That one came out easy, which is amazing. This one stands a... it's still a little hot. Let me do this one first. There we go. And that's what usually happens. It leaves behind some of the pins. That's okay. I mean, you just have to desolder them. They're easier to deal with, you know, one at a time. I'll give them... that one just wiggled right out, not a big deal. Kind of wiggle test them all, see if any of them are ready. Yeah, 2 of them pull out. Those last 2 are still a little stuck in there. So I'm going to just heat those back up and do another solder suck on them. And because I know they're hot, let's grab them with pliers. There we go, nice and easy. One looks like it's so close, but not completely out. See if that did it. There we go. Okay, got that, and power connector's cool now, so that just pulled right out. Alright, so if you're not OCD about it, then we're basically done. If you want, you can remove these additional pin headers. I guess, I don't know, it might be nice to get them out of the way just for soldering these, but it doesn't really matter too much. Alright, so for the interest of time, I'll leave those on there, even though it'll bother my OCD. Let's go ahead and throw these away. Alright, so that board's prepped. Our HDMI switch is prepped as far as removing components on both. We've already done the removal on this SD card reader. So now let's go ahead and solder on. Let me clean up my desolder gun because we're done with that. And turn that off. And then I will turn on my regular soldering station. Okay, so what we're going to do here is put on this level switchboard, or level converter I should say. And what that does is allows the 5-volt signal from the Arduino to control a 3.3 volt signal on the HDMI switch. So, happy coincidence for us is that these pins here, these 5 pins through holes there, are wired. 2 of them are, actually 3 of them I guess. Well, 2 are wired to what we need. One of them is wired to the power switch and one's wired to the input switch, selector switch. And that's what my project is doing. The whole Origin Arduino project, it sends a signal to this switch box to virtually push this button to switch the input on the HDMI switch. So that's what we're setting up now. So these first 2 down closest to my finger, bottom of the shot there, are those first 2 there are controlling that power and input selector. The next 2 are the power, 3.3 volts, and ground. I think ground is the middle one if I remember right. And then that last one there we're not using, but I do go ahead and wire the pin header to it just because it adds some stability. So I'm going to take this, it comes with 6 pins on here. I'm going to take my side cutters and just cut 1 pin off so that it can go into the 5 pin holes here, through holes. Do the long side down then I'm gonna, let's get it up here on the wood block. Okay. Now I've got something to push against. So I'm going to go ahead and heat that up and solder that in. And I like to try to get it as straight as I can. It looks, let's let gravity help us out here a little bit. There, that looks pretty good. Okay, so now I've got one in place that'll help, you know, hold it straight up and down. I can go by and get the others. And that middle one is ground, so it takes a little more to heat up. Okay, got that side done. And then my level converter here goes, let me verify by looking at a previous one. Yeah, so it goes with the low voltage on the switch side and with the component side facing down. And so LV1 should not be going to anything. It's just LV2 through 4. 4 is closest to my fingernail right now. And a lot of times what I'll do to help get this nice and straight is I'll take the extra pin header that comes with these level converters and just kind of stick it in the other side. And that gives me something to push against to keep this flat. I like to do both sides first, the far edges, LV4 and LV2, and then go back, you know, once it's nice and stable and straight. And it's kind of hard to tell on the camera. Sorry, I don't have a better camera for this. But now I can go back and just solder in the remaining points here. Again, ground will take a little more heat. Now, I don't want to do it just yet because it's going to be hot, but these pins here, the excess pins that stick out through, I like to cut those down just because they are pretty long. And I will warn you that those shoot off like crazy when you, with a lot of force when you cut them off. So what I've been doing is using side cutters and the wood block here, and I just keep it, let me see if I can do it where you can see it. I guess I can do it even though they're hot. I'm not going to touch them, so it doesn't matter. I do it with the wood block right below it and keep it nice and tight to the wood block and cut them, and there it comes off pretty easily and it doesn't hurt anybody or go flying across the room and I step on it later. And that one actually stuck into the wood. That one shot off even though I was kind of protecting it there. Ended up on the floor somewhere. But anyway, oh, there it is. Alright, throw that away. Throw these guys away. Alright, we got that done. Throw away some of this excess here. Don't use that pin header. Alright, so we got that, got that. I've got a bunch of these cutters because these things are amazing. Hakko CHP 170. I've got a pair that I've really kind of abused that I use for that because they're already a little bit dinged up, so it doesn't matter what kind of damage I do to them. Alright, I think we're going to take a little soldering break here and get some of the wires prepped. So I'm going to clean up my tip and then turn off the iron for now. Alright, I'm back. Took me a little while to find these infrared receivers, but I got them. And the good news is that now I have the part number that I found in the bag. These are TSOP 34438-ND. And I believe, yeah, I got them from DigiKey. They sell them all over the place, but it needs to be this specific size. Anyways, there you have it. A lot of the ones that are out there, infrared receivers, have that like metal coating, or not coating, but like bars over top of the receiver, and they just look so ugly. So I really like these black ones that can kind of blend into the case as much as possible. Alright, so now we got those, we got to make the wires. And that, I won't show the whole thing, but I'll give you an idea of how I do it. What I do is I take, I bought a box of this, Remington wire, Remington Industries. I got it off of eBay, but I'm sure they sell wire plenty of other places. This just was convenient, decent price, and I like that it comes kind of set up as a dispenser with all the different colors and everything. So I'm using the color code basically that we learned as kids, Roy G. Biv. We don't have indigo here, but we'll count purple as either indigo or violet or both. So I am making for the HDMI switches here. We're doing Roy G. Biv in reverse here. Red, orange, yellow, green, blue, purple, and then we got two more over here that we're going to use, brown and then gray. I have standardized on black and white for black is the positive voltage coming in, and white is our negative or neutral or whatever it is. I'm sorry, I'm again self-taught electronics. I do a lot of AC voltage stuff, so in house wiring, white is your neutral and black is your hot wire. And so I kind of stuck with that just because it made sense to me, and because it left the red available for the Roy G. Biv thing to help me out mentally making these things. You're welcome to disagree with that. I totally get it. If you're a DC guy, been doing electronics work, my understanding, I guess, is that red is normally the positive and black is normally the negative. And if you want to switch up the color codes, by all means go for it, but this is what I've done. So anyway, let's get red, orange, yellow, green, blue, purple, brown, and where is my gray? There it is. Gray. And hopefully they're all free enough. Yeah, so you need to pull enough wire to do however many switches you're doing. You're going to need, in this case, I'm only doing one switch, so I really don't need that many, but I'm going to make a little bit of extra because I'll probably make some more of these in the future. So most things are going to be 24 centimeters long for these switch hookup connectors. Those are the red through gray wires here, the 8-wire bundle, and then we're also going to do a white and a black wire bundle for power. We'll need a little bit more of those because we're powering more than just the switch. We're powering the SD card reader and the Arduino. But I'll pull them separately, and then what I do once I pull enough for however many, I got a tangle here somewhere, that one's stuck. There we go. What I'll do is I will actually take a clamp like this, and I will clamp these to the edge of my table, nice and tight. And then I'll pull it across the room and cut it and put the other end into my drill. And then just spin the drill to make nice neat wire bundles that I can work with. And I just put it right into the chuck as is. I don't, do any kind of connector or whatever. Just jam them in there, tighten the chuck down, and give it a spin, and they'll tighten right up into nice, easy to use bundles. I won't show that on camera just because you can't really see it anyway, and I don't feel like moving my camera setup, but you get the idea. Okay, so now I've got a couple of wire bundles here. I already did one for the SD card reader. That's the only one that's, well, not the only one. The SD card reader and the infrared receiver are different. Infrared has a 3-wire bundle with black, white, and gray. So I've got that here. I already cut these to length. And I did one with red, orange, yellow, and green. Just a 4-wire bundle for the SD card reader. So those two are done. I'm going to show you here how I prep the other stuff. So now that I got a nice wire bundle for cable management here, let's cut the end off so it's nice and straight. Same thing on the black and white. And then I take these, I put out a measuring tape here, and most of these things are going to be 24 centimeters. So let's go ahead and mark them, well, eyeball it, whatever, get it lined up and then cut it. And I twist these before I cut them because as you twist them together it gets a little shorter. So you want to make sure that you get that done first. Okay. So in this case, I'm only going to need one of these bundles because this is only a single switch model. If I was making more than one, then I would go ahead and cut the rest of these. So I'm done with the colored wire bundle there. And get the rest out of the way. I'm going to use that for a later project. But I am going to need some more of the power cords. So we've got a power cord coming in from the back of the unit. So we got one there. Then we need one that goes to a power distribution board. And then we're going to have, which I realize I don't have that out. Here's the power distribution boards. I got these from Amazon. I can put the link in there, but bus board. These come in 4 units to a wafer here, or whatever they're called, PCB, and unfortunately they're not all the same size. So I'm going to break these apart, and you'll see what I mean. So this one has the extra green strip on the bottom, which I don't know why they didn't make them consistent. I designed the 3D print for this one that has the green strip at the bottom. This would fit perfectly fine. Might need to revise the 3D model a little bit to make it tighter for this, but I've basically just been using these ones with the green strip for now. Eventually I'll find a use for the other ones, or change the model to use them. Alright, so that is that. So we got the power cord coming from the back, from the input, from house power or whatever, to this. We need one going from this to the HDMI switch, one going from this to the SD card reader, and one going from this to the Arduino. So we got to make 3 more of these things. There's 1, 2, 3. Okay, got those. I've already got my 2 that I showed you earlier for the SD card reader and the infrared receiver here. I only need one. I just got another one for later use. Set that aside for now. Alright, throw that away. Clean up my area here a little bit. Okay, so we've got, let me go through my list of wires here. We've got the SD card reader data, SD card reader power, infrared power and data. We've got our 8-wire bundle for the data for the switch, power cord for the switch, power cord for the Arduino, and power cord for the device as a whole. The only thing else we're going to need as far as wiring is we need a short 4cm black wire. So let me get my wire box here and cut 4cm. I think I found that to be a little on the short side. Let's make it a little longer, maybe 6 centimeters. It doesn't matter too much, but it just helps to solder if you got a little bit more. Okay, so this is going to be the jumper wire from the DC input jack to the switch, power switch, so that we can turn the whole device off with a switch. It's not technically necessary, but I like having that as an option. You can leave it out and change the 3D print model if you want. Okay, and then we also need a 14cm black wire to go from our level converter here, the red guy here, to the other side over here by where the DC input jack used to be. There's actually a little pad we're going to solder to on the board there. So that needs to be 14 centimeters. Okay. And then we need a short white wire, which is just going from the level converter down to the center pad of where the infrared receiver used to be. And that is 4 centimeters. That's where I got the 4cm. I was looking at the wrong one. The DC input jack wasn't supposed to be 6 centimeters, it was supposed to be 10. That's why it looked long. Or short, rather. So let's cut one more 10cm wire. My bad. I knew 4 looked wrong. Okay. I think that should be it as far as wiring is concerned. So set those all off to the side, get my wire box out of the way. Alright, let's go ahead and bring our soldering iron. Well, no, I guess I need to strip these first. So this part sucks. And there's got to be a better way of doing this, but this is what I've come up with. I untwist the ends a little bit and just go through and strip each one a little bit. On this 14cm black wire, the one end you want to cut kind of short, or strip kind of short, because it, sorry for the brightness here, you can see that end is longer. I stripped that end longer than the other side. The long end goes into the level converter and the short end goes to this spot here labeled F1. And that is just because that's a pad that we're soldering to. You can actually, that pad is electrically connected to this. At any rate, the pad is electrically connected, but rather than try to put 2 wires through here, I just soldered one to this pad and one through there. You can do 2 wires through there if you want, not a big deal. Okay, let's go ahead and get our iron heated back up. And now we got plenty of soldering to do. The infrared one is a little bit evil. I hate doing this one. So, got to cut off all but a little bit of the connector. You need to leave enough to solder a wire to. Alright. And then I've got the bulged side, the side that faces out, the actual receiver. Got that facing down. And what I'm going to do, I've got another one here that's done, I'll show you. So the bulged side is this side here. So looking at the back of it, you can see it goes black, white, gray. So I'm going to take my wire here and it'll go black, white, gray. Now this is one spot, the only spot, where we need a little bit of heat shrink tubing. And so I've got a box of that stuff here. I've been using red, so I'll go with that for consistency. It doesn't matter at all. And just cut about, maybe a centimeter of that. And make sure you put that over top of the white one and get it down away from the heat for when we solder here. Alright. Looks like I might have stripped a little bit too much off of this, so let's cut those down a little bit. Get my wood block in here. I do have some of these like alligator clip wire holder dealies here. This kind of helps, to hold on to the infrared receiver there. But ultimately this process is going to fight you no matter what you do, I think. So I like to get a little bit of solder on these first, and by little I mean enough to have like a little solder ball there. Okay. And then let's go ahead and try to solder these in place. And it's tough because you gotta heat it up, hold it in place until it dries, and then you gotta line up all of the next ones without messing up your first connection there. And you want to err on the side of, the wire can rotate all the way around the pin there. You want to err on the side of the wire being on the back, because you don't want bulk on the side that's facing down right now, which will be facing forward in the final project. I got too hot to hold. I lost it. Alright, let's try this with some pliers here. Normally I can just do it with my hands, but okay. That wasn't too bad. Alright, so let that cool for just a little bit. I'm going to get out my hot air gun, heat gun. I've just got a cheapie here that I picked up from Amazon. And I just use this to shrink the heat shrink tubing. So once that's cool enough, which it is now, I can pull that heat shrink tubing up over that center one. This is just to prevent anything from shorting out here. Alright, so that's in place. Let's go ahead and get the wires kind of situated where I want them to be. Alright, and then we'll just heat this up. That's it, and that's all I use that tool for. Set that aside. And that's all I use the alligator clips for too. That one stupid little thing. Kind of a pain in the butt. Alright. We got that prepped. Let's prep the SD card reader. Yeah, I thought I had a finished one I could show on camera, but I guess I don't. I can't really see it on this one, but they do. It's the power comes in on the left, and they're labeled here ground and VCC, so white, black, and then MISO and MOSI and SCK and CS. So that's going to go in our color code: red, orange, yellow, green. So let's go ahead and get one of the power wires in there first, I suppose. And we're soldering from the front to the back. So where you see the actual SD reader, that's the front. The wires go in that side, and then we solder on the other side, the flat side. It doesn't have any components. Alright, and now you get to see how much my technique needs help. I don't know how people solder without 3 hands. Seems like there's always something that wants to slide away. In this case, the ground wire was coming out. And as I soldered the black wire in there, the heat actually melts some of the insulation around the wire, and it retracts a little bit, which is kind of a pain because you don't want it to retract too much where it can potentially short something out if the wires bend and touch. And I don't know if that's a problem with the Remington wire that I have, or if that's common with all wires, but that's definitely something I've been fighting on this project. If you push the wire in to combat the insulation creeping back away from the solder point there, then that insulation, the plastic, can actually melt into the solder joint and then contaminate the solder joint and give you not a terribly good connection on that. So that's something to watch out for, especially on the power board. I have that problem a lot when I'm doing this one. Alright, so I'm always tempted to try to get them all in at once and solder them all in at once, and it never works out very well if I try that, so I'm going to do the first 2 here. Got those in place. Sorry you can't really see this on camera, but make sure you heat up both the wire and the through hole there at the same time so that the solder sticks to both of them. And we can trim off the excess here. Obviously watch, because some of it's a little hot right now. And that is going to actually matter because there's not a ton of room behind this in the 3D print, so you don't want wires sticking out too much, and you don't want it to short out either if they bend over on top of each other or something. I forgot to mention that the solder on you're soldering on the back of the SD card reader for support, but the solder actually matters most on the front of it. So it's a little awkward. Make sure that you've got a little wire, little bare wire showing here, and make sure that you get some solder in between, holding that wire down to the pad on the PCB here on this side, because this side doesn't connect to anything at all. It's just structural. This side is what matters. So you want to really make sure that you solder both sides on the SD card reader. One for support, so that you're not. If you only solder this side, that matters electrically, then if any strain gets put on these wires, it'll rip the pads right off the board, unless they're soldered on the back as well. So just make sure you get both sides on this. Alright, so that's done. Let's go ahead and prep our HDMI board here. And I guess we can center that a little bit better on the image there. Okay, so here is, I'm going to go ahead and let's just do the big wire bundle first, I suppose. Doesn't really matter too much what order we go in here, but I have, like in the past, I've done the level converter to F1 hookup before, and I had an issue where just as I'm holding the soldering iron here to solder these LED wires, it gets kind of close to that black wire that goes across the board. So I never have melted it, but I could see how you could if you accidentally bump into it with the soldering iron. So I'm going to recommend doing these first, I suppose, because of that. Red, orange, yellow. Now this is reverse order. We start over here with LED 6 with red, and it's going to be the right of the two holes. There's a little arrow in between the holes for the LEDs there that actually points towards the one you want. That's how I remember it. So the right one, the one the arrow is pointing towards, put the wire through there. It doesn't really matter top or bottom. I like to do everything from the bottom. I think it provides a little cleaner of a look that way, but electrically it doesn't make a difference. It's kind of nice, you can push down on the board to bend the wires nice and flat, and it'll help hold it in place. Just checking out my solder connections here. Looks pretty good. And then the brown and gray go to high voltage 4 for brown, HV4, and HV3 for gray. Let's go ahead and get our white wire in. It goes to the middle of IC4 there, where the infrared connector used to be. Since it's a ground wire, it does take a little longer to heat up. And I like to, bend that back and hide it a little underneath the board. But I try to make sure that it does not touch any of these other pins there, so I bend it in such a way that it, goes out of the way of those. Just if anything ever, the jacket got a little damaged, on the plastic coating on the wire got damaged or something, I don't want it shorting out against something there. Okay, looks good. And then let's get our black wire in. Remember, one side was stripped a little longer, so the longer side goes in over here. And then I'm going to route it underneath the brown and gray wires and up through. And then I try to give it a nice clear path, routing it around other components. It probably doesn't matter too much, but I don't want it getting too hot if it gets close to the main IC here, and I don't want it shorting out anything if the jacket got a little damaged or something. Shouldn't be. Better not be a problem, but just in case. And I normally do the power wire first, but I'm going to try it this time since I've got this ready. I'm going to go ahead and solder this in. It may come loose as I heat up to solder the power wire later, but let's get on this F1 pad a nice big solder ball to put this in, and then I just line this up, heat up the wire and the solder ball. Just hold it for a second till it solidifies. And just make sure it didn't short out against, like if you had too much wire, it might short out against the other pad there or something. But it's not. It looks good. And route it away from this IC2 chip here. What is that called? Voltage regulator. That's it. Just trying to come up with it. So that's where it switches from the 5 volts that's coming in down to the 3.3 that the rest of the board uses. So that component can get a little hot. Alright, let's get the power wire on that first. Okay, flip it over. You don't have to do it this way, but this is the way I do it. So, because these two here, that one and that one are electrically connected. That one and that one. But I use this one for my white wire because if I use this one, it gets pretty close to the plastic support that goes into this hole here. There's a screw that goes through there into the plastic. It will work if you do it there. You have to be a little more careful about your wire management. So I recommend not using that hole and just using this one. Alright, and this, because it does have so much metal there, I turn up the temp on my soldering iron because it takes forever to heat this. I had it at 750 Fahrenheit for most everything, but I turned it up to 850 for this, which some electronics people are probably screaming at me, oh, that's too hot or whatever. Well, maybe it is. I don't know. I haven't had any issues with it. So I'm going to go ahead and heat that up and get my white wire through that hole. I'll check the other side in a minute to make sure that it's okay. And let's get our black wire loaded up full of solder first. We want a lot of solder there. Actually, it looks pretty good. Normally I have more trouble with these. That went pretty smoothly. And this doesn't matter at all, I'm just OCD, so there was a little solder sculpture, I guess, sticking up there from where I desoldered the DC input jack before. So I was just smoothing that out so it didn't have a sharp edge. Alright, I'm going to turn my soldering iron back down before I forget. Alright, so we're going to route that kind of just down and back. You know, want to avoid that hole there. That hole, and but don't have it go too close to the edge because there's going to be a support here on this corner, so it'll come through around there. And that looks good. I'm going to trim off the excess on the top of the board here, and it looks like my F1 connector was fine, so I didn't have to worry about that. That 14 centimeter black wire that comes over. Okay, nothing pokey sticking up there. Looks good. Alright, so that's ready. I think we are basically at the assembly phase here. Let's go ahead and start. This is where some of the wire lengths adjusted slightly. It's not too bad actually, but I'm going to go ahead and cut these. Well, let's straighten them out. Cut them to the same length. And we're going to strip the ends of them off. Alright, so these are designed to go in order: red, orange, yellow, green, blue, violet, purple, brown, and gray. Let me double check my documentation here to make sure I'm doing the right one. Starting on pin 22, then going down 22, 24, 26, and so on. I might get a couple of them tacked in just to help hold the wire in place, and then I'll go back and get the rest in place. Much as I want to do more than 3 at a time, that seems to be about the safe limit. I'm using solid core wire here because it acts more like pins. It strips easier. It doesn't have the little strands that want to split apart as you're trying to push them through a through hole here. A lot of people like the flexibility of stranded wire, and I get it, but me personally, I prefer to work with solid core wire. Okay, looks pretty good. My only complaint is my yellow wire has a little bit of exposed wire sticking through on the other side. I don't think it's enough to cause a problem, but I'm going to push it through a little bit just in case. I just like to check and make sure there isn't, something that could potentially short out there. Alright. Those are in place. We got to do our SD card reader, our infrared sensor, power wire, and the wire for the next gen display, which I haven't gotten out of the box yet. Okay, I'll leave that in the package for now. So these come with, this is stranded wire. Funny that I was just talking about that. These come with the connectors on the end. I just cut those off because I'm going to solder them in place. And strip away a little bit of the insulation. Since this is stranded wire, I've found that it helps a little bit to tin the end a little bit first. So I try to straighten it out and twist it a little bit, but it seems like no matter how much I do that, if I don't pre-tin it, it's one of the strands is going to push away and shoot off a weird direction as I try to put them through the holes there. So that should help. Alright, so I've been powering the next gen display right off the Arduino here. It seems to work fine. So this is where it messes up my color code though. So their 5 volts is red. So there's a 5 volt right above our red connector that's going into red wire going into pin 22. So we can wire the red for their 5 volts, the next gen 5 volts there. Alright, let me double check my notes. I think yellow is pin 16. Yeah, yellow wire to pin 16, blue to pin 17. And during assembly, it, especially with the larger switches like the 25 port, you really have to pay attention to cable management the whole time, because this is all soldered together, so you gotta make sure that everything is staying out of the way of other components and not getting tangled as you're going. So I'm gonna kind of pay attention to that here. It doesn't matter as much with a single port, or a single switch rather, version, but oh, and as you probably figured out, we are going from the top of the Arduino down to the bottom. That probably is obvious, makes logical sense to do that, but you could electrically do it the other way, but then the plastic of the enclosure would get in the way of some of the connections. Alright, our next gen cable's in place. Let's get our, let's see, SD card reader is pins 50 to 53, and that's red, orange, yellow, green. So red and 50, orange and 51, yellow, green, 52 and 53. Just checking out my work for anything that could short out. Orange wire's sticking out a little bit much. we go. Okay. Done. And then we got our infrared connector, our infrared sensor. That is going to be the white wire just goes to the ground at the bottom, which again, my color code versus standard electronics kind of messes you up here. You're going to have a white wire going next to the black wire. Both of them are ground, but sorry about that. But I came up with that early on, and this was not a concern at that point, and by the time it was, I didn't want to change it. Okay, go ahead and get that ground wire in first. And then we're going to do power and data. Data is first. Data is pin 48, and power is 49. Gray is data, so gray is 48, and power is 49. That's good. You'll notice I didn't remove the DCN jack on this. I made the case so that it covers that up, but it's still there, but it can't be accessed, and really, why remove it if we don't have to? Too much work. So, all right. Anyways, oh, we got to get our power wires in now. So ground and voltage in on the power rail section there. Way too much wire sticking up there, so let's push those. Oh, plus I shorted it out. Huh. That's why you check these things. Much better. Alright, let's go ahead and clean up the bottom of this, keeping in mind that some of them are hot. That's it for that. The only thing we got to do now is the power board assembly there. Solder everything to the power bank and start assembling it in the plastic enclosure. I'm just doing a quick cleanup here, and then we will get to that. So for the power board, we are only using this bus board here. The top row and the bottom row have a bus that goes all the way across, and that's what we need. You can see on the back of it here. So we're going to have the wire come through this side that has the print on it, and then go through to the back, and we want like all the white wires to be on this top part in a row. Any hole really, but I do have an order I like to go in, and then the same thing on the bottom for the black wires. So I'm going to make this wire here that's just loose right now my first wire that'll be coming in from the DC input jack and power switch on the back. So I strip away a little bit of that, loosen the twist enough to safely reach both of them, and don't use the far left or far right row, or column I guess I should say, because that is maybe slightly obscured by the, or maybe completely obscured, I forget, by the holder that holds this whole thing in place. Yeah, it's completely blocked. So there's a little plastic piece that holds this board down, and that's what it grabs onto, is that first column and last column. So you can do anything you want other than those. I go ahead and start with the second column with my white and black wire that's coming in from outside there, or from the power jack there. And let's go ahead and get those in place, and I'm just trying to hold it down onto the soldering mat here, just to keep the wires in place while I solder. Again, I could really use a third hand for this. Alright, and then from that point I like to go in order. I skip a row just visually it tells me where the different components are. So I skip a column, I should say, and then the next open column I put the HDMI switch. Bend some of the wire here to take some of the strain off of this. Let's go ahead and get that second one in. Alright, and then I start from the other side and I take kind of a physical layout approach. So the physical layout of this is that the SD card reader is on the front of the case. So I'll do the SD card reader as the rightmost connectors on this board, power board here. So not the far right one because that's going to be covered up, but the first available hole on the right. Alright, and then I skip a hole, a column there, and do the Arduino power next. Okay, looks pretty good. Let's trim that up. Alright, we are ready to do the back panel where the DC input jack is. I'm going to go ahead and separate these out a little bit, untwist them. And this is a part that I commonly forget. Take this nut off of the DC input jack and let's get it on the wire here. Now it's only going to go on the white wire, and then this little 10 centimeter black wire that we cut earlier is going to go through there as well. You don't want to forget to put that jack or that nut in there, because then you got to desolder stuff to get it in place. Alright, so here's my back panel, and I'm going to go ahead. You can solder some of this stuff ahead of time without putting it through the panel first, and I guess that protects the panel a little bit, but it's not that hard to solder once it's in the panel. And actually now I can put the nut in place first. So let's go ahead and just do that, get it out of the way. Now the threads on this are plastic and pretty flimsy on the actual DC input jack, so you got to make sure that it doesn't strip out. So you want it tight but not overly tight, because it'll very easily just break those threads. I always do it with the shorter pin. You can see how they're different lengths here. I always do it with the shorter pin facing up, so you know, the towards my finger here. And then let's go ahead and push the power switch through. Obviously make sure that that is the correct orientation as well. Logically up is on, so the 1 should be on the top. Alright, and here you'll see, I mean, this wire may be a little excessive, but I designed it this way where the wire is a little too long, so that if you need to desolder something, you can like push this clip out of the plastic so that it's, you know, you're not heating it up in place. So I like to kind of pre-bend these into little hooks, not too tight, and then hook them onto the holes there, clamp it down so it holds in place. And then let's go ahead and try to do this where you can see it. Solder that in place. And I have to hold this. My hand may block it a little bit. We'll see if I can do this. Got a nice big solder blob there to hold that in place. So the black wire goes to that little short one, and then that goes from there to the switch. It doesn't technically matter which pin you use on the back of the, or which connector you use on the back of the switch, but I use the bottom one and then as the input from the DC jack, and then the top one is the output to the switch power board, the power distribution board. Alright, so let's go ahead and get that. And these are, you know, pretty fragile, like plastic components here, so you don't want to leave heat on it for too long because you can actually melt that. And then the white wire to the bottom one here. I guess maybe I should have done that one first, but it doesn't matter too much. Watch my soldering iron with these cables I'm soldering past here. Okay, that's in place. I think we are done soldering. Should be. I'm going to clean my soldering iron tip up a little bit and then turn that off to cool down. So, now we gotta assemble. And I just have a big old box of screws here. But what we're using are Phillips number 4. We're using 1/4-inch ones for the HDMI switch. We'll need 2 of those for that. We're going to use 4 1/4-inch ones for the screen, the LCD screen. And then everything else is going to be Phillips number 4, 3/4-inch long. I'm using rounded head thread forming for plastic. I got these from McMaster Carr. I just had a ton of them, so that's what I used. I'm sure anything of similar size should work. You just have to make sure that the threads don't split the plastic, because that is pretty easy to do if they're not the exact right size. These ones are intended to go through plastic, so this should be pretty easy for that, pretty good for that. So 2, 4, 6 for the bottom. We got, I believe, 3 for the front panel infrared receiver and SD card mount, and then 2 for the Arduino itself. The Arduino can be either the 1/4-inch or the 3/8-inch long screws. It really doesn't matter. But I just figure since it's, you know, pretty important, I use the longer screws since I can. And I think that is everything I need screws for. Let's start assembly and see what oh, the power distribution board. So we need 2 for that, and that has to be the 3/8-inch ones as well. So there we go. That should be everything now. Alright, I always start with the back. It's just 2 screws per switch. Hold the switch flush with the back while you screw it in. Got that. Grab some of the other components here. Let's go ahead and get our power distribution board in. Got to get the plastic holder piece over it, which thankfully you don't have to worry about doing that ahead of the wiring. Alright, so let's go ahead and get that in place. Line up the screw holes and put those 3/8 inch screws in place. Keep it nice and tight while you're doing this. Okay, got that. The side panels I didn't bother modifying for different versions, so even though this is only a 1-switch back panel, it's got the holders for 3 switches. I just isn't worth my time to make extra side panel models when this is compatible with 3 different models, you know, a 1-switch, a 2-switch, or a 3-switch version. This switch doesn't, or the side panel doesn't have anything to connect over there, so let's do the front panel assembly. Oh, actually, I've been doing the 6-switch version. We don't need as many any screws for the front panel LCD screen. So I was wrong about that. We're not using 4 short screws for that at all. On the larger, the 7-inch screen, you do use 4 screws, but haven't done one of these in a few months. Alright, let's get the infrared and SD card reader in place. So the infrared is kind of wedged in place in this hole, and you can push it through a little bit with, you know, either your finger or I like to use like a screwdriver or something like that, pliers, you know, anything blunt object to get it pushed in place. But you don't want to push too hard because you want it to be flush, but you don't want it to, you know, come crashing through the front. It should be a pretty tight fit. And then once I got that in place, let's get the SD card reader in its spot there. And then this bracket goes over top. Oh, it's 4 screws. I was 1 short. Alright, so we'll get that screwed down, and that holds both of these in place. So remove the protective film on the LCD screen, throw that away, and then this, gotta remember which way, I think it goes this way on this model. Yeah, so the connector on the screen goes towards the SD card reader. And it's a pressure fit, and there's a couple little catches for it to slide under there. And then we need to hook up the cable to it. Well, I guess let's get start assembly here before we go too far ahead of ourselves. Let's get the bottom panel connected. So I'm actually going to take the screen out because I don't want to risk it falling out while I'm doing the rest of the assembly. Okay. This is where it gets a little funky because you got a lot of things to hold all at the same time. Line up that back part there, and it doesn't really matter whether the cable goes above or below. I'm going to route it above. There, get that connector lined up and make sure everything goes in the right slot, and then we drop it on the bottom panel here, and there's a groove for it to slide into, and then flip the whole thing over and screw in those first 3 bottom panel screws. Keep it nice and tight while you're doing that so it holds in place. And don't over tighten them. I mean, this is plastic. They should be snug, but you don't have to really crank down on them. Okay. Now that the back is in place, it has a little more structure to work with. We can go ahead and get Let's do the Arduino next. Put the USB port through the hole on the side. That's for programming the Arduino, updating the code or whatever. And we'll go ahead and screw the Arduino down. Just 2 screws here. Alright, and then you'll see I didn't put in the screws on the bottom of the front until I get this in. So let's get our wires kind of tucked out of the way. Get our screen back in there. I guess I can go ahead and it might be easier to hook up the screen connector first before I put it in there. Yeah, that is kind of a tight connection. Alright, so I got that in. We'll slide this in place. Drops down into the groove. Should hear it kind of click into place there. And then hold it nice and tight, flip it over. Then we got to get, I'm going to have to grab it one more screw, but we got to get these held in place. That hole on the bottom there is for the SD card reader that is on the next-gen display. And unfortunately that can't be used for storage. That is only for programming the next-gen display. So we use this to upload the code to the display, and then we use the USB port to upload the code to the Arduino, and we use the SD card reader that's in here for storage for the Arduino. So it is what it is. A little awkward, but that's the way it had to be done as far as I'm aware. If you know a better way, please share it. And I do know that the Arduino has some built-in memory, but I know that that memory has limited write cycles. It's a high number, but it is limited. And I felt like the SD card, you know, gives me a lot more storage options and space. And if it ever goes bad, just pop it open, pull the SD card out, put a new one in, and I'm done. Instead of resoldering all the connections on the Arduino and all that. So it's just a little bit of future-proofing and giving me some space for different options. So hopefully that will be of some use. That's pretty much it. I mean, I haven't been plugging this in and testing it along the way. Now would be a good time to do that. I do have a power cord here, so I suppose I can do that real quick. It should just boot up with, I haven't uploaded any code to this or anything, so it should just show you the next-gen default display at this point. So let's turn the switch off, make sure that power connector's in nice and snug, and then when I turn the switch on, there's my next-gen display. And on the larger 7-inch screen versions, the screen is actually mounted upside down, like 180 degrees of what this is. So it'll be upside down when you first turn it on. That's normal. But when you program it with the code for the origin switch, it takes that into account and rotates everything 180 degrees. So that's it for this. Let's turn that off. I'll upload the code later and test that out. So all we got to do is put on the top panel. This is a pressure fit panel. These tabs just lock in to little ridges on this. And that way if you ever need to modify anything, you just pull it off. It is made to be tight, so make sure that these connectors are pushed in nice and tight. The side panels should all be snug. It does take a little bit of elbow grease. There we go. And that's it for that. I have some little rubber feet that go on the bottom. I'm not going to put those on until I upload the code and completely test it, but I recommend just covering over the 4 screws in the corner, just because for stability's sake that's the best place. I mean, if you want to leave the screws accessible, I suppose you could move them in, the feet in just a little bit, but I don't think it's a big deal to cover them up. So there you have it. It was kind of a long video, hopefully not too boring, but wanted to document the entire process from beginning to end here. Alright, hope you guys enjoyed the video. I don't plan on making these like en masse. I don't plan on making money off of this project. I'm open sourcing it so that the community can pick it up and hopefully do some cool things with it. I do have a full-time job and a family and a lot of things to do, so I just this takes a lot of time to build these. This build here was probably the fastest one I've ever done, and I haven't timed it. I think it's somewhere in the 2.5 to 3 hour range for the electronics component for just a 5-port version. It's going to take longer for the bigger ones. But just in the 3D printing alone to make a case for this, for the larger case, I think takes upwards of 2, maybe 3 days to print a single case. And granted, I don't have to babysit it the entire time, but I do have to babysit it to some extent, and make sure that the print doesn't fail and stuff doesn't clog up my printer and that kind of stuff. If some modder somewhere wants to start making these, then hey, that's great. I wouldn't mind if you throw me a little something for the effort that I've put into it, but I'm not seeking to profit from this. So, all right, let me know what you think in the comments below. If you got any great ideas for the project or want to contribute, by all means get involved. It's open source, so anybody can contribute to it, and we'd love to see what you can do with it and what you can add to it, and where this project can go. Thanks for watching.